want to start? Sure.
Yeah.
I mean, I'm just going to re-echo my talk. I think that there's a lot of effort on optical PCIe. I think that should continue. That's valuable. I think there's a lot of effort on low power, sort of 100 gig, 200 gig SerDes, either LPO, CPO. I think that has to continue. I don't know that OCP has a significant role to play in sort of that ongoing effort. I think if we're going to talk about sort of future opens, we should be talking about something like 2 terabit per second links, terabyte per second links. I think that, I made the case this is where HBM is going. I think this is the case where memory links are going to go, and I think when we have them, we'll build systems around them. That's an open. It's a big challenge. It's not something I think that can be done today, but I think it's something that would be super valuable in these future composed systems working on, doubling AI, ML model sizes every other year or every 4 months. 2 cents worth.
Thanks. So I think what would be really useful, and OCP could do a great job, is actually predict the optical market seriously. So what we saw was that one sobering chart just on, sorry, Drew, I mean, you're painting a bright picture, but yet light counting's telling us, look at all this small percentage of Ethernet and it's all copper. Now, I don't believe that. I think there is a sliver of optics there because we know NVLink, which is several generations ahead of PCI, as you've said, they're actually using a lot of optics, unfortunately, all VCSELs. That's too bad. But I think in a white paper, a really credible optical market prediction could be very helpful. Because one of the problems we have is these overhyped predictions, when they don't come true, then the investors really pull back. So I think that could be something incredibly useful, and I know light counting could help out people like Meta, but actually having a realistic optical computer I/O prediction, be PCIe, NVLink, whatever else, I think that'd be very helpful to guide the industry and investments.
Thank you.
David?
Sure. I'd like to actually echo something that Chris said. Overhyping something is really bad. I mean, a company like mine, people ask me and say, well, whatever happened to silicon photonics? Because people were led to believe that when silicon photonics happened, it'd be like the singularity. It would just take off and take over everything. And I tell them, silicon photonics has been hugely impactful for our whole industry. But they don't believe it because they thought there'd be this, this boom where everything would happen. Okay, so that's why we shouldn't overhype. The other comment I have is I want to echo something that Andy said this morning on CXL over PCIe, and it's several generations behind NVLink, and that's a real gap, and that's like kind of the elephant in the room. Everybody says how great CXL is, and I would say CXL would be great if we dropped all the PCIe baggage and just moved a couple generations ahead immediately, but I don't see that happening.
And
maybe this is all too controversial.
Oh, that's fine. That's what the open session's for. That's the consequence of a single vendor versus 800 companies that are in a consortium. Report?
Michael, your request is for each speaker to single out one item for
Sure,
carrying into future work stream or something?
Yeah.
Is that correct?
Sure, yeah.
I would vote for one-to-one sparing. I think because of the compelling case that VCSEL makes, the one weakness that you could argue is the onboard failure. And with one-to-one sparing, we completely dramatically change the reliability game. So that would be one thing I would add to the work stream in future.
Okay, thank you.
Yeah, so I think the one thing that I think the OCP can do, which it's already done, it's got a great history of standardizing form factors for the data center. And so I think at least for the CXL PCI over optics market, the one spot is the AOC. As I showed, my company's doing PCI cards, OCP cards, those are pretty, they're already standard, but for the AOC, the SIG has gotten behind the CDFP, but I think what OCP can do is really define for the data center what the AOC form factor should look like.
Okay, good.
Yeah, I think from
There we go. From the HPC, I guess I kind of feel underrepresented hearing all these talks about AI and all this cool stuff. But I guess the one thing is, well, HPC exists. Let's start with that. And there are many important applications that by themselves don't have the market share to drive that much innovation. So I think on the hardware side at least and the integration. But there's still important workloads for science and many other domains. So where OCP can help is help HPC and related scientific applications tack on some of the advancements that are going to come out of this consortium and make use of them.
Good, thanks.
If to say one thing, I would one more +1 for optical CXL. The way it's going right now with a optical working group, PCIe optical working groups, is essentially okay. Well, it's just optical nuisance to electrical ecosystem that goes forward on its own pace. But you know, in this conference and before, people been thinking like, why PCIe, why CXL should be limited by electrical? Okay, so maybe there is a work stream that needs to start to specify optically optimized, right? CXL, in what does it mean, and maybe provide those inputs to the PCIe SIG.
Oh, okay. Liaison.
Okay. Yeah, I think we've seen a lot of interesting and wonderful things at the session here, and we've seen what the hyperscalers are asking for, and how they're able to really scale this into high volume. This goes into things that they just have to have high yield and so the question is, there's a lot of standard organizations out there that are all working on separate pieces. There's the PCI SIG, there's the OIF, there's IEEE, various things. Is there some role that the OCP could play in stitching together the industry and a lot of these efforts somehow? Coordinating them? LPO. LPO is a good and LPO, yeah, okay.
Just to echo what David and I think also Chris kind of alluded to, I believe that we may be setting an unrealistic expectation in terms of especially power and some potential, this huge, up in terms of the volume. I would say if you look at the past, decade or so, people have tried very hard to reduce power and cost, all those. I think people will continue to do that. But just because AI, bandwidth is doubling, I mean, unless there's some really quantum, singularity happens here and something changes, what is it going to drive, to make this kind of a bandwidth, that requires, dramatic reduction in power and cost? Is it possible that, these AI workload, they're going to realize, yeah, there is a cost here to pay. There's a power here to pay. And yeah, maybe some of these applications are not going to be as cost effective. And wouldn't that end up to be the self-limiting, because you just can't deliver the cost power that you expect, to drive this kind of, volume, Isn't that a possibility?
Okay, thank you.
So in terms of sort of optical optimized interface, I think UCIe is one of them, I guess, because can we to see how UCIe to optical could work better? That eliminates the SerDes. I mean, that eliminates the limitations of PCIe speeds not being fast enough and all of that. So I would vote for looking at how UCIe can be pushed to, make optical retimer specification more solid there. And I also want to second, maybe surprisingly second, the sparing idea. And maybe not limited to particular ratio or particular technology, but generally sparing as a concept for lasers. I think it's a good idea.
yeah, there'll be no hope to get to the numbers that Andy Beckelsheim talked about without some sort of redundancy built into the.
Well, yeah. I mean, people can choose. They want reliability or picojoules per bit. Or, I mean, if it is cold, maybe it doesn't add to power.
Yeah. Karen?
Yeah, I guess I like the idea of the roadmap that maybe lays out what's possible as opposed to just what would be desirable. You know, that to kind of focus efforts and set expectations. And then also the sparing, I'd like to see work on sparing strategies for external laser sources.
Yeah. Okay, anybody else? Okay, thank you for coming.